ANSYS Simulation, Lecture 15, Piezoelectric Material. And this is a piezoelectric material, and this is steel bar. And we enter ANSYS workbench, and we'll run a static structure analysis. And the key point of this problem is the material. So we'll duplicate the steel and rename it to piezo. And the density of the piezoelectric will be 4.5. And then we'll drag orthotropic elasticity to piezo material. And we'll enter these material properties. For the Young's moduli, Poisson's ratio, shear modulus. So here we enter mechanical properties of the piezo material, and then we'll go back to project and enter ANSYS mechanical. And we'll enter the electrical properties of the piezo material in commands. So the piezo ceramic will be piezo material, and the beam will be structural steel. And we will insert commands for electrical properties of the piezo material. These are the dielectric constants, and this is the piezo matrix. So we have finished with the properties of the piezo material, and the contact will be frictionless. And the mesh is very important, that we map all the surfaces and choose the method for all the volumes to be hexagonal dominant, and all the surfaces are quad four-sided, and will generate mesh. And then for the support, I'll define fixed support on these two surfaces. And for the loading, I'll define voltage for electrodes. So I first define the electrodes. This is the positive electrode. So I'll create name selection as positive electrode. And then I'll hide this volume and define this surface to be negative electrode. So I create two name selections, and now I can place a command for the loading. D command, positive electrode, volt, 700 volt. D command, negative electrode, volt, 0 volt. So these are the voltage placed upon both electrodes. And since we have written commands, so the unit of the commands has to be the same as the command the unit on workbench. So we will choose manual unit and use MKS unit and save all the commands. Okay, so for the solution, the result will be total deformation and equivalent stress, and I'll solve for the problem. And this is the deformation of the beam. You can see that when we apply a 700 volt on the electrode, the piezoelectric material is expanded and then push the cantilever beam upward. So if you define the frictionless support contact, and if the polarity of the electrode is reversed, you will not see the deformation because the volume will be contracting instead of expanding. So make sure that the positive direction and negative direction should be as we demonstrated. Otherwise, you will not see the deformation. So this is the problem of a piezoelectric material pushing a cantilever beam. And we will use this material in the next lecture on a harmonic response problem.